In this video, we're going to learn how to draw a sketch of a polynomial equation by using our knowledge of zeros and end behavior. So before we draw our first sketch, let's talk about the key details that we'll have to find in order to create a fairly accurate sketch. So the first thing we're going to need to find is we're going to need to find our X-intercepts. So these are where we cross the x-axis, and these occur whenever y is equal to 0. So those are the first pieces of information we're going to find. After that, we're also going to find our y-intercept, simply because we can find that pretty easily by simply plugging in when x is equal to 0. So we're going to find all of our intercepts, both x and y-intercepts, and then we're going to find our degree and our leading coefficient. And we're going to tie these two pieces of information together to use the appropriate end behavior for our graph. So those are the four key pieces of information that we'll be finding in order to create our sketch. So let's jump in and start our first example here. So we're going to find x-intercepts, y-intercepts, and end behavior. So let's start by finding the x-intercepts of this particular polynomial. And the strategy that we know to use to find our x-intercepts right now is the factoring strategy. So we can find when this entire function equals 0. So we'll plug 0 in for y, and then we will factor the rest of this. So what I noticed just by looking at this off the top of my head is I noticed that this function has a greatest common factor of 3. So I'm going to start by factoring out our greatest common factor of 3. So here we have 0 is equal to 3 times x to the power of 4 minus 2x squared plus 1. So we've factored out our 3. Then from here, I notice that because I have x to the 4th and x squared and then a constant, this is a situation where I can use the ABC method to factor a trinomial. So I started off by finding my a value is equal to 1, my b value is equal to -2, and my c value is equal to 1. And I'm looking for two numbers that multiply to be 1 but add to be -2. And when I think through all of my factors of 1, I know that the only way this can happen is if I have -1 and -1. So I can rewrite this here to be x to the 4th minus 1x squared minus 1x squared plus 1. I then look for the greatest common factor in each pair. So in this first pair, it's just x squared. So that becomes x squared minus 1. And in the second pair, it's a -1. So that becomes x squared minus 1 as well. And then because I have those matching parenthesis pieces right here, I can group together the x squared and the -1. And then I can have the parenthesis piece. So now I need to bring down my 3. And then I need to make sure that this doesn't need to be factored any further. And so if I take a look at these pieces that still contain an x squared, what I notice is that both of them happen to be a difference of squares. So I notice that this is an x squared minus 1 squared. And this is also an x squared minus a 1 squared. So this first one here becomes x minus 1, x plus 1. And then this second piece here also becomes an x minus 1, x plus 1. So we've used a couple of different factoring strategies here. We used greatest common factor at the top, then the ABC method, and then difference of squares to factor this polynomial completely. But now that we've factored it completely, remember we can set each piece here equal to 0. So if we do that here, this 3 being set equal to 0 wouldn't result in anything because there's no variable. Then x minus 1 equals 0. If we added the 1 to each side, we would get x is equal to 1. X plus 1 equal to 0. We'd subtract 1 from each side, so we'd have x equals -1. Then we have x minus 1 again equal to 0. We'd add the 1 to each side, so we'd have x equals 1. And then we have x plus 1, which would result in an x equals negative 1. So what I'm noticing here is that I have two x-intercepts. So these are where we cross the x-axis. I have two x-intercepts. I have x equals 1, which appears twice, and I have x equals negative 1, which appears twice. So previously we talked about the importance of knowing if something appears twice, and that's because if an x-intercept appears an even number of times, that means that we are going to do what's called bounce off of that point at the x-intercept. So because we're appearing twice here, we know that at x equals 1, so right here, and x equals negative 1, we're not actually going to cross the x-axis, we're just going to bounce off the x-axis. And you'll see what I mean when I actually draw the graph. So keep that in mind. If an x-intercept appears an even number of times, we're going to bounce off of the x-intercept. So now I'm going to find a couple more pieces of information. The next piece of information I'm going to find is I'm going to find my Y-intercept. And so I find my Y-intercept by finding when x is equal to 0. So if I go back to my original function, I know that x is equal to 0 occurs when I plug 0 in for x. So I have 3 times 0 to the power of 4 minus 6 times 0 squared plus 3. Well, this becomes 0 minus 0 plus 3, so I know my y-intercept occurs at 3. So I know I'm going to cross the y-intercept right here at y is equal to 3, because that is when x equals 0 and y equals 3. Now, my last piece of information that I need to find here is I need to find my end behavior, because that helps me to draw the entire graph. So I find my degree, and my degree is equal to 4, which is even, which tells me that my ends of my graph are the same. And then I find that my leading coefficient is 3, which is positive. So that tells me that the right side of my graph is pointing up. So believe it or not, all of this key information is going to help me draw a sketch of my graph. So I'm going to tie all of this information together. So I know that the right side of my graph is pointing up. So somewhere over here, my graph is pointing up. And then I hit my x-intercept. And then because my x-intercept of x equals 1 appears an even number of times, I don't actually cross there. I bounce. And I go up to my y-intercept. And then I come back down to my x-intercept, and again, because x equals negative 1 appears twice, we bounce off the graph, and we go back up. So notice, your graph does not need to be perfect here. It just needs to be a little sketch. So notice that all of the information I found, my x-intercepts, my y-intercept, and my end behavior, are all in my sketch. And those are the key pieces I'll be looking for in your sketch. Have you found all x-intercepts and included them? Have you found your y-intercept and included that? And did you find your end behavior and make sure that it matches what it should be doing according to the polynomial? Is it matching the degree and leading coefficient requirements? So let's go through this same process one more time. So here we start off and we're going to find our x-intercepts of the graph. And we know that we do that by finding when y is equal to 0. And we know that we utilize our factoring strategy. So I start off by looking for a greatest common factor, which in this case is 3x squared. So I factor out my 3x squared, and I'm left with x squared plus x minus 6. So I've used the greatest common factor to start. Then from here I notice that the ABC method does in fact apply. So I have A is equal to 1, B is equal to 1, and C is equal to -6. So then from here I'm looking for two numbers that multiply to be what A times C is, so that's -6, and add to be 1, which in this case is going to be a +3 and a -2. So then I can go over to my polynomial and I can rewrite this further. So this becomes x squared plus 3x minus 2x minus 6. So I look at each pair. This first pair has a greatest common factor of x. And when I factor that out, I'm left with x plus 3. Then in my second pair, I can factor out a -2, which when I do that also becomes x plus 3. And then because I have matching parenthesis parts, I can group together the x minus 2 and multiply it by the x plus 3. So I was able to use my ABC method and the greatest common factor here to factor this polynomial completely. So now what I need to do is I need to solve each of these little parts to find what x would equal if y was equal to 0. So this first part here says 3x squared is equal to 0. So we would have x squared is equal to 0 if we divided both sides by 3, and we find that x is equal to 0. Now because this had an exponent of 2, x equals 0 actually appears twice, so we need to make note of that. X equals 0 appears twice, so it's going to simply bounce off the graph, because if it appears an even number of times, which in this case the squared tells us that it's appearing an even number of times, it is going to bounce off the graph. Then x minus 2, if we set that equal to 0, we would have to add 2 to both sides, so we would get x equals 2, and then we have x plus 3 set equal to 0, and if we subtracted 3 from each side, we would get x equals -3. Both of these only appear once, and because they appear an odd number of times, like normal, that is where we are going to cross on the graph. So essentially what we're going to have is we're going to have two x-intercepts where we cross the graph and one x-intercept where we bounce off the graph. So I'm going to go and mark these on my graph. So I have -3, 0, and 2. Now from here in this problem, I can find my y-intercept, but I actually already kind of did because it aligns with one of my x-intercepts. But if I find my y-intercept point, that is where x is equal to 0. So if I plug that in, I get 3 times 0 to the 4th plus 3 times 0 cubed minus 18 times 0 squared, which becomes 0 plus 0 minus 0, which just equals 0. So what we expect to see here is we expect to see us crossing at 0, 0, which we've already kind of put on our graph here. You can see that with our x-intercept. Then our last thing that we need to find is we need to find our end behavior that we expect to see, which in this case, if I look carefully, I can see my degree is equal to 4. So I'm going to expect that my graph is going to have the same ends, so either both pointing up or both pointing down. And then because my leading coefficient is equal to 3 and that is positive, my right side of my graph is going to point up. So this one is going to look similar but a little bit different than my last graph. So remember, we're going to cross through at 2 and -3 when we cross those x-intercepts, and then we're going to bounce off of 0. So here we start up on the right side, we cross through at 2, we then don't know where we're going to switch directions right now, and that's okay. We're just going to come back up and bounce off of 0, come back up and cross here. So it's okay if your W isn't perfect and it's not going down quite as far as it needs to. What I'm looking for here is, can you identify your X-intercepts? So you have a double at 0, a 2, and a -3. Can you then identify your Y-intercept, and can you tie in your end behavior, in this case where both ends are going the same direction and the right side starts pointing up?